Good afternoon, everyone. So we're going to continue today talking some more about trigonometric identities, specifically kind of how to solve them more in detail. So to give you an identity, like an expression that I say is true, that you're actually be able to prove that it is true. Okay. Trigonometric identities are really kind of like little logic puzzles. Okay, as you're trying to make one side be equal to the other side. Okay, they take somebody used to. Okay, right? Like admittedly they can be tricky to run through. Okay, but as you practice them and keep trying them out, you're going to get better at them. Okay, and you're going to be able to work them through. Okay, so just a little preamble here, and then we're just going to get right into solving them. Okay, so to solve or to prove that a trigonometric identity, so you're trying to prove it's true, as just said, you must manipulate one or sometimes both of the sides of the equation to show they're equal to each other. Okay. Now, when I say both, you still have to do them separately. Like you can't move things back and forth across the equal sign. Okay, you just have to work with one side and try to make it look like the other side. Okay. Or you can work both sides separately and hopefully get them to match at some point. Okay, so some of the things that we might have to do here, right? So the solution will involve, or often will involve, making substitutions of things we already know, right? Okay, well, expanding, factoring, combining fractions, things like that. Okay, so while we're working through these, okay, it might be handy for you to have the list of identities we had yesterday handy. Might have that out of your notes so you can kind of look at them because we'll use those now and then to make changes in equations. Okay, so again, it's like solving a puzzle. Okay, I'm going to give some general tips here, but the best way to get good at these is just to practice, to keep trying them, right, attacking them, trying to make them work, okay, until you get the hang of it. And start recognizing some of the common patterns and things that you need to be able to do here. So first one, okay, is to take the messier side or the bigger side, the one that has more stuff, okay, and try to make it simpler, right? So if one side has like 5 things in it, and the other side only has 2 or 3, okay, it probably means you need to make a change, right? Make a substitution on the side with more terms and get it shrunken down to the other one. Okay, a decent strategy can be to try to get to everything in terms of sine and cosine, and then do some manipulations afterwards. Okay, it's not always the best approach. Okay, but right, sometimes it will make it messier at first. But yeah, in the long run, usually getting it in terms of sine and cosine will help you bring it around. Okay, if you have 2 fractions sitting there, most likely you're going to have to add them together, especially if the other side of the identity doesn't have 2 fractions. If it's only got one, that's a pretty good sign. You should just add the fractions. So that's using our rational skills from earlier to do that. Okay, and the last thing is looking for squares, right? So if there's something squared in the equation, okay, it could mean one of 2 things. Okay, one, it could mean that you actually have something that kind of looks like a quadratic and that you might need to factor it. Okay, or okay, it could mean you have to use the Pythagorean identity that we looked at yesterday, right? Sine squared plus cos squared equals 1, and use that to make some kind of a change. Okay, so again, those are kind of my general tips, but in this note, we're just going to go through, we're going to do 4 of them in the note, and then in practice, there's just a bunch of them. Okay, and again, I can't say this enough. The key thing is just to try them, right? So when we get to that stage where you're practicing, again, you might want to get into small groups, like team up with some people and really go after them to try to get them work through. Okay, so here's our first one. We're going to prove that sine of theta times secant of theta is equal to tan theta. All right. So the left-hand side is ever so slightly bigger than the right-hand side. So let's start with that. The left-hand side is sine theta secant theta. Okay, the goal is to get to tangent. Okay, so we know the tangent is in terms of sine and cosine. So let's make that change first. Okay, secant theta we know is really the same as 1 over cosine of theta. Okay, that was one of our reciprocal identities from yesterday. Okay, now I have sine times 1 over cos. So if I want to multiply these together, and again, it's a little fraction view, this would be like sine over 1. So if I multiply those together, I'm going to get sine theta over cos theta. Okay, and again, we know from the identities yesterday that sine over cos is equal to tan. Okay, and boom, we're already done. Okay, this equals the right-hand side, and we're finished. Okay. Okay, obviously that was a nice one. Okay, it will build up to slightly more complicated things as we go through. Okay, example 2. Prove that 2 sine squared, take away 1, is equal to sine squared minus cosine squared. Okay, so for this one, okay, they've both got 2 terms. So I don't think one side is particularly easier than the other to start with. Okay, however, okay, a little clue here, or a nice thing, I have a 1 there. Okay, and I can see on the other side, right, I currently have sine right here, but I need a cosine. I don't have a cosine at the moment. So we know one of our identities involves a 1, right? That sine squared plus cos squared equals 1. So that's going to be a possible starting point here, right? I need to see cosine. I don't currently have it, but I can get it from the 1. So on the left-hand side, we start with our 2 sine squared theta minus 1. Okay, I know one of my identities says that 1 is equal to sine squared theta plus cos squared theta. Okay. Next thing I'm going to do is just expand the bracket so that negative sign applies to both terms. So I have 2 sine squared theta minus sine squared theta minus cos squared theta, because I'm subtracting both things in the brackets. Okay, and our final step now is just to clean it up. Okay, 2 sine squareds minus a single sine squared, right? That'd be kind of like doing what's 2x squared minus x squared. So that gives me my sine squared, and I have my minus cosine squared, and I'm done. Equals right hand side. Okay, and we're good. Okay, example 3. Leveling up here a little bit. Prove that 1 over sine squared plus 1 over cos squared is equal to 1 over sine squared cos squared. Okay, that may look a little weird because we don't normally do that with fractions, right? You don't just put the denominators together. But trigonometry, this is an identity, and now we're going to show how that works. Okay, so again, in those clues there, I said that if you got 2 fractions, you can add them, right? On my left-hand side, I have 2 fractions. On this side, I only have 1. So realistically, I must have to add those together. Again, we'll start with the left-hand side. And it's just a coincidence that it's always been the left-hand side so far. We have 1 over sine squared plus 1 over cos squared. Okay, I have to add 2 fractions together. How do I do that? Okay, I need a common denominator. So, right, I'm going to need, on my first fraction, what is it missing in the denominator? It needs a co-squared. So I need sine squared co-squared. Okay, which means I need an extra co-squared on the top. Okay, same with the other one. It's missing sine squared. So I need an extra sine squared on the top. Okay. So the next one I'm going to do two things. Okay, one, they have the same denominator now. So we put it all over one denominator. My denominator is sine squared theta times co-squared theta. Okay, in the numerator, I just have 1 times co-squared and 1 times sine. So I really just have a co-squared theta plus sine squared theta. Okay, so that's looking pretty good. I've got it into one fraction. Okay, unfortunately, I have a bit more stuff on the top than on the right-hand side. But, okay, once again, there's that lovely identity. I have a co-squared and a sine squared. So, right, sine squared plus co-squared is equal to 1. So now I have 1 over sine squared co-squared, and we did it. Okay, that's equal to the right-hand side. Okay. All right, last one. And yeah, this is the one that Carter would call the Papa Bear question, I guess. Prove that sine theta plus cos theta equals 1 plus 2 sine theta cos theta over sine theta plus cos theta. Okay, so the messier side is the right-hand side. So we're going to start with that one. Okay, is 1 plus 2 sine theta cos theta over sine theta plus cos theta. Okay, so what can we do here? Okay, well, like the one we did earlier, a little hint might be we have the 1, okay, and we have an identity that can replace the 1. So we may as well play with it and see what we can do. Okay. So while I'm writing the next line down, just one thing I should point out. As you're learning to do these, okay, it's quite possible that you might try something and you kind of get into a dead end and it doesn't work. Like you think it might work and it doesn't seem to help you at all. Okay, that's okay. But it just means you might have to try some other approach, okay, to see if you can work it out. Okay, the other thing is you got to be really good with your algebra skills, okay, to make this work its way through. Okay. So, okay. Right, did that really help? I got sine squared plus cos squared. Okay. So again, I'm showing you this one because it's a trick that does come up from time to time. Okay, although I should never call it a trick, a technique. Okay, something to notice. I'm just going to take the cos squared and move it to the end of the equation. Okay, sine squared plus cos squared. Oh, pardon me. I said I was going to move that. Plus 2 sine theta cos theta plus cos squared theta all over sine plus cos. Okay, so the reason I did that, I'm going to do a little aside here. So the part that's in red, I'm about to write. Okay, it's up to you if you want to write it down. Okay, you don't have to, but it might help you see what's going on. Okay, so we'll do a little aside here. Okay, even though it's in terms of sines and cosines, okay, kind of looks like this. Let's say if my sine was x, and I know that's not probably the best way to do it, but right, this could look like x squared plus 2 xy plus y squared. Right? If I said my sine squared is like an x, and my cosquared is like a y, okay, this is what the thing on the top would look like. Okay. Now, that's something we actually talked about back at the start. Okay, we can factor these pretty much the same way I factor a quadratic. Okay, so right, it has the extra part with a y hanging around here. So multiplies to what? Adds to what? Okay, my n term has a 1, multiplies to 1. Okay, middle term is 2, adds to 2. Okay, my numbers would be 1 and 1. Okay, so this would factor into x plus y and x plus y. Okay, or x plus y squared. Okay. So returning to what I had before, okay, that means that top part was factorable. So this factors into, right, x was my sine, so sine plus cosine, and sine plus cosine over sine plus cosine. Okay, so now that we've done the factoring, okay, it's kind of become clear what's going to happen here. Okay, I've got 3 of these, so I can cancel 1 with the one in the denominator, and I get left with sine theta plus cos theta, which was the left hand side. Okay, there's a lot going on in that one, right? Recognizing you have to turn the 1 into sine squared plus cos squared, and then noticing that it's quadratic and that you are able to factor it. Okay, so that was definitely a difficult one to see what's going on. Okay, but again, the only way you're going to get good at them is to practice them and try running them through. So there's the homework for this. Okay, it's number 5, 8, and again, if those ones are good and you want to challenge yourself, okay, try number 12. But definitely try to work through 5 and 8. Okay, yes, this has like, parts A to E or A to F in them, so there's lots of opportunity for practice. Okay, again, what I might recommend, okay, is, get into small groups to work on these. Okay, if you want to, get so small like a table, okay, or go to the whiteboard and work on them together. Okay, but yeah, do it as a small team. Okay, talk to each other. Try things out. See what you can get it to do. All right. So, thank you very much for watching, and I will see you tomorrow.